Welcome to this explainer. Okay, today we're tackling something huge, literally one of the highest stakes problems in modern manufacturing, which is catastrophic machine failure. In an automated production line, the control computer is the absolute center of the universe. If it goes down, you're instantly bleeding money in astronomical downtime costs. For decades, manufacturers have been relying on simple binary signals to monitor these complex systems, essentially just waiting for a machine to break before they actually do anything about it. But right now, we're right in the middle of a massive shift from that basic binary feedback to true industrial intelligence. So let's look at how upgrading your automation architecture completely changes the game.
What if you could literally hear your machine screaming for help before they actually broke down? It's kind of like a medical mystery, right? Machines rarely just die out of nowhere. Long before a line comes to a screeching halt, components are silently suffering. We're talking about impending heat collapse from a failing fan or gradual sensor drift. But standard proximity switches, they leave you completely blind to these internal terminal conditions. They only tell you if something is there or not, just on or off. Today, we're going to explore how we can take those silent binary signals and transform them into deep diagnostic transparency, basically catching the disease before it becomes fatal to your production schedule.
Okay, let's dive into this. On the left side here, you've got your traditional binary proximity switches. These essentially act as an information vacuum. They give you a simple yes or no signal, leaving you completely in the dark about what's actually happening inside the sensor itself. But on the right, look at these smart IO-Link sensors. Completely different ballgame. They are bidirectional, so they don't just send a signal down the line, they actually talk back. They give you real-time temperature data, they monitor internal resistance, and they diagnose drift before it causes a failure. You are swapping out passive blindness for real predictive power.
Section 1. EtherCAT, the central nervous system.
So before you can add smart senses, your machine needs a central nervous system that can actually handle high-speed data without choking. Enter EtherCAT. This has really become the global standard for ultra-fast real-time industrial Ethernet. Beckhoff introduced it way back in 2003, and the core spec is still amazingly compatible today. Then, in 2005, they rolled out Safety over EtherCAT, which uses a secure black channel approach to safely isolate control data. Flash forward to 2016, and EtherCAT P completely revolutionizes wiring by combining power and data on just one standard cable. And by 2018, we get EtherCAT G and G10 launched for massive data transmission rates. It's a system built from the ground up for pure high-performance automation. Let's break down exactly why these features matter so much for a smart factory. First up, nanosecond synchronization. This drastically cuts down the wait times between your process steps, really boosting efficiency. Then there's the flexibility. We're talking support for up to 65,535 devices in line, tree, or star setups with no restrictions. Third, integrated safety. Functional safety is baked right into the architecture, fulfilling strict SIL 3 requirements. But honestly, the real magic here is the on-the-fly processing. As an Ethernet frame moves downstream, each node literally reads the data addressed to it and writes its own data back without even stopping. It makes EtherCAT the absolute fastest industrial Ethernet technology out there. And that incredible on-the-fly architecture leaves us to a really vital number: a 25 to 30% reduction in CPU load compared to other bus systems, assuming the same cycle time. Because the network itself is so insanely efficient at handling data exchange on the fly, it actually frees up the brain of the machine. Your central computer isn't bogged down playing traffic hop, it can dedicate all its processing power to complex control tasks.
Section 2. IO-Link, the smart senses.
Now, what's really interesting about this piece of hardware is how it bridges the gap. Taking our biological analogy from the nervous system to the sensory organs, this is the Beckhoff EJ6224 IO-Link master module. This right here is the crucial link between that blazing fast EtherCAT field bus level we just talked about and the individual smart sensors out on your machines. It's a compact, powerful module that manages the whole flow of intelligence back and forth. Now, I want to clarify something really important. IO-Link is not a field bus itself. It's an intelligent point-to-point connection. It allows for bidirectional parameterization and data exchange between that master module we just saw and up to 4 connected devices. Think of it as a literal two-way conversation between the machine's brain and its fingertips. The master asks, "Hey, how are you feeling?" And the sensor can actually reply, "I'm running a little hot today." And honestly, integrating this technology is shockingly seamless. You don't need a team of programmers spending weeks doing manual network tuning. Look at this. Step 1, you simply connect your IO-Link sensor to the master port. Step 2, the TwinCAT software automatically does a device scan to find the sensor and imports its IOD. That's the IO device description, which contains all the parameters, diagnostic data, and vendor info. Step 3, bidirectional real-time diagnostic data instantly starts flowing. It is essentially plug-and-play industrial intelligence. Section 3, diagnostic transparency. And this brilliantly illustrates what happens once that data is flowing. We get true diagnostic transparency. Notice how the TwinCAT diag history actively logs event qualifiers and exact timestamps, right down to the millisecond, sorting everything into information, warnings, or errors. The master module is actively reporting stuff like short circuits or overheating straight from the sensors. So instead of a machine just stopping and leaving you guessing, you get this highly detailed ledger of the exact symptoms that led up to the issue. So the big takeaway here is that we are turning raw data into actionable industrial intelligence. With IO-Link, you're getting early detection of impending heat collapse,
You get immediate short circuit warnings. You can even monitor internal sensor drift to catch a component slowly falling out of calibration. There are even lost frame counters to help diagnose those really annoying wiring or electromagnetic interference issues. We are completely shifting the paradigm here. We're moving from reactive maintenance, scrambling to fix a broken machine while hemorrhaging thousands of dollars a minute, to predictive maintenance, where you just casually replace a degrading sensor during a scheduled coffee break.
Section 4. The cabinet-free future. Let's zoom out to the macro level for a second, because this smart architecture completely revolutionizes physical factory design. To see why this is so necessary, just look at this labor breakdown for building traditional machines. A staggering 49% of that time is wasted on manual wiring alone. Almost half of the labor is just routing copper cables into these massive space-consuming control cabinets. It is a huge bottleneck for both cost and efficiency.
And this is exactly where the MX system comes into play. It really represents the logical, ultimate conclusion of pairing EtherCAT with smart IO-Link sensors. The MX system completely replaces the traditional control cabinet with decentralized, modular intelligence. So instead of running miles of wires back to a giant metal box, taking up valuable hall space, the intelligence is distributed right onto the machine itself.
The benefits of this system are absolutely transformative. First off, you're looking at an 80% reduction in circuit diagrams and parts lists, because all that complex wiring is eliminated. It features 100% EtherCAT integration, meaning the system is fully digital. Plus, with no traditional control cabinets, it requires zero additional floor space, dramatically shrinking the physical footprint of your factory. And here's why this is absolutely crucial today. Cutting down on space, materials, and copper wiring directly hits those ESG, environment, social, and governance, sustainability goals that modern manufacturers are strictly evaluated on by investors. It's not just about speed anymore. It's about building a leaner, greener operation.
Which leaves us with this final, provocative thought for this explainer. Look at your own production lines. If a crucial automated line went down tomorrow, would your system have given you the detailed warnings and diagnostic transparency to know exactly why it was going to happen before it actually failed? Or are your machines suffering in silence while you're still listening in simple reactive binary? Upgrading from basic switches to IO-Link and EtherCAT isn't just some tech upgrade. It's literally the difference between running your factory and letting your factory run you.
Let's study more and like, share, and subscribe for such more content. And comment something you want to learn.